Hello, I'm going to work more with the slope-intercept form of the equation of a line. In Candace's examples, she always knew the vertical intercept. I'm going to show you how you can use the form even if you don't know the vertical intercept. We're going to find the equation of a line given the slope and a point on the line other than the vertical intercept. And then I'm going to work a couple of applications of linear equations. So let's find the equation of a line given the slope and a point on the line other than the vertical intercept. Let's find the equation of form y equals mx plus b for the line that passes through the point 3, -1 and has a slope of m equals 2. Alrighty, let's start with the easy part. We know what m is. Since m equals 2, the equation has form y equals 2x plus b. What we don't know is b, and we don't know the vertical intercept. So we're going to have to come up with some other strategy. I see that the point 3, -1 is on the line. That means whatever equation I come up with, 3, -1 better satisfy that equation. So since y equals -1 when x equals 3, what I'm going to do is I'm going to take my y equals 2x plus b equation, I'm going to replace x with 3, y with -1, and see what b is. So -1 equals 2 times 3 plus b. So -1 equals 6 plus b. And when I subtract 6 from both sides of the equation, I'm left with -7 equals b. Our value of b is -7. It appears that our equation is y equals 2x plus -7, which is 2x minus 7. Let's check our equation by graphing the described line and testing a point from that line in our equation. So the described line was the line that passes through the point 3, -1 with a slope of 2. That's what I'm going to graph. So I'm going to go to the point 3, -1, and I'm going to draw a line through that point that has a slope of 2. I can think of 2 as 2 over 1. That would be a rise of 2, a run of 1. Let's rise 2, run 1. Rise 2, run 1. I also could go -2 over -1. Rise -2, run -1. Let's get out the straight edge and connect the dots. Here's a graph of the described line. Let's make sure y equals 2x minus 7 is an equation for that line. The way I'm going to check is I'm going to pick one of the points on the line other than the one that I was given. Let's take the point 4, 1 and make sure that that point satisfies our equation. So if x equals 4, then let's see what y is. Y is 2 times 4 minus 7. 2 times 4 minus 7 is 8 minus 7, which is 1. It checks. So let's write our conclusion. Our conclusion is that the equation of the line is y equals 2x minus 7. Now there were a whole lot of steps to that problem-solving process, so let's see several examples so you can get lots of practice on going through the steps. Let's find the equation of form y equals mt plus b for the line that passes through the point -3, 4 and has a slope of m equals -2. Well, Our starting point is that since m equals -2, the equation has form y equals -2t plus b. Since y is 4 when t is -3, we have 4 equals -2 times -3 plus b. -2 times -3 is 6, so 4 equals 6 plus b. Subtracting 6 from both sides of this equation, I have -2 equals b. It appears that our equation is y equals -2t plus -2, which is the same as -2. Let's check our equation by graphing the described line and testing a point from that line in our equation. When you do your check, make sure you graph the described line so that you can then check your equation. So our described line goes through the point -3, 4, and has a slope of -2. I can think -2 over +1. Down to right 1, down to right 1. Look where I'm landed. I landed on the t-intercept. The t-intercept is the point -1, 0. I think I'll use that as my checkpoint after I get out my straight edge and connect the dots. Let's make sure -1, 0 satisfies our proposed equation. If t equals -1, then the value of y is -2 times -1 minus 2. That's 2 minus 2, which is 0. Our answer checks. The point -1, 0 satisfies our equation. Let's write our conclusion. The equation of the line is y equals -2t minus 2. New problem. Let's find the equation of form z equals mx plus b for the line that passes through the point -1, 3 and has a slope of m equals 0. Since m equals 0, the equation has form z equals 0x plus b. 0 times x is just 0. Z just equals b. Z equals a constant. Our vertical variable equals a constant. You know what kind of line that is? It's a horizontal line. Since the line passes through the point -1, 3, the constant value of z must be the z coordinate, which is 3. Let's check our equation by graphing the described line and testing a point from that line in our equation. So we're going through the point -1, 3, and we have a slope of 0. The only way we get 0 is if we divide a non-zero into 0. So our rise needs to be 0 regardless of what our run is. If our run is 4, the rise is 0. If our run is -2, the rise is 0. Sure enough, we've got ourselves a horizontal line. And it looks to me like one of the points on our horizontal line is the point 3, 3. The z coordinate is 3. Our equation checks. So let's go ahead and state our conclusion. The equation of the line is z equals 3. One more example. Let's find the equation of form z equals mt plus b for the line that passes through the point 2, 0 and has a slope of m equals 2/5. Since m equals 2/5, the equation has form z equals 2/5 t plus b. Since z equals 0 when t equals 2, it must be the case that 0 equals 2/5 times 2. I'm going to go ahead and write that 2 as 2 over 1 to help me with the arithmetic, plus b. 2/5 times 2 over 1 is 4/5, so 0 equals 4/5 plus b. And when I subtract 4/5 from both sides of this equation, I'm left with -4/5 equals b. So our proposed solution here is the equation z equals 2/5 t minus 4/5. Let's check. Let's go ahead and graph the line to the point 2, 0 with a slope of 2/5. 2/5 could be thought of as rise of 2 over run of 5. Rise 2, run 5. If I try to rise 2 and run 5 again, I'm off my grid. Let's think about the slope as -2 over -5. Rise -2, run -5. Rise -2, run -5. Let's get out the straight edge, which I'm doing, even though you can't see it, and let's go ahead and connect the dots. Now let's go ahead and find a point on this line and check it in our equation. I see the point 7, 2. Let's check that point. If t equals 7, then the value of z is 2/5 times 7 over 1 minus 4/5. That's 14/5 minus 4/5. Since I have a common denominator, I can go ahead and subtract 4 from 14. That gives me 10 over 5, which is 2. The point 7, 2 does satisfy our equation. Let's state our conclusion. Our conclusion is that the equation of the line is z equals 2/5 times t minus 4/5. Alrighty, let's move on and work a couple of application problems. The Grand Canyon. This should be a nice, serene example. Uncle Jeb took his nephew Timmy to visit the Grand Canyon. Much to Uncle Jeb's horror, little Timmy decided to chuck a rock off the top of the canyon. Figure 1, which is on the next screen, shows the speed, which we're going to identify as v, measured in feet per second, at which the rock was moving t seconds after the rock left Timmy's hand. The slope of the line and a point on the line are shown in the figure. So here's our graph. Our horizontal axis is the amount of time the rock has been in free fall. That's the amount of time it's been since the rock left Timmy's hand. The vertical axis is the speed of the rock in feet per second. We're told one of the points is 1.7567. 1 3/4 seconds after the rock left Timmy's hand, the rock was moving 67 feet per second. The slope is 32 feet per second per second. The speed increases at a rate of 32 feet per second per second. Every second the rock is in free fall, the speed is 32 feet per second faster than it was the second before. If we want to find the speed the rock was moving the instant it left little Timmy's hand, I think a good plan would be to find an equation that describes this line, because t equals 0 is the instant the rock left Timmy's hand, so the vertical intercept, which we can read right off our equation, will be the answer to the question. So let's go ahead and copy down the pertinent data from the graph, And the pertinent data is the fact that the numeric value of the slope is 32 and that the line passes through the point 1.75, 67. And let's give ourselves some room to work. Since the slope of the line is 32, the form of the equation of this line must be v equals 32 times t plus b. We also know that the line passes through the point 1.7567. That tells me that the value of v is 67. At the instant, the value of t is 1.75. Let's get out a calculator to help us with our arithmetic. Let's see, we need to take 32 and multiply that by 1.75. So that gives me 56. So we have 67 equals 56 plus b. And when we subtract 56 from both sides of the equation, we get b equals 11. So the equation of the line is v equals 32t plus 11. So we've got v equals 32t plus 11. We're trying to find the speed the rock was moving the instant it left little Timmy's hand. The instant the rock left little Timmy's hand is t equals 0. When t equals 0, v equals 11. That's why the point 0, 11 is the vertical intercept. The speed the rock was moving when it left little Timmy's hand was 11 feet per second. How long after the rock left Timmy's hand was the rock moving at a speed of 100 feet per second? Well, 100 is the value of our vertical coordinate because the vertical coordinate is the speed of the rock. So let's go to 100 on the vertical axis. Let's move over to the line, and then let's take that point and project it down to the t-axis. I can see that the time when the rock was moving at 100 feet per second is somewhere between 2 and 3 seconds. But I certainly can't tell from the graph exactly what that value is. So let's do some calculating. I'm going to go ahead and replace v with 100. And I'm going to solve the resultant equation for t. Subtracting 11 from both sides of the equation, I have 89 equals 32t. Dividing both sides of the equation by 32, I have t equals 89 over 32. I don't know about you, but I don't have a real good sense about the number 89 over 32, so I'm going to get out the calculator and change this to a decimal so I do have some sense. So let's see, if I take 89 and divide by 32, I get a whole bunch of digits. I don't think I need all those digits. I think I'm just going to round to 2.8. So when I do that, I need to make sure that I use the old squiggly equals to communicate that I've rounded. T is about 2.8. So let's write our conclusion. The rock was moving at a speed of 100 feet per second, about 2.8 seconds after it left Timmy's hand. Well, it looks like we're leaving the Grand Canyon. Let's see where we're going. Nguyen decided to join her local health club. The club offers two types of memberships. A lifetime membership requires a one-time payment of $750 plus $3.49 a month starting the first month. A month-to-month membership requires no upfront fee, but the monthly dues are $34.99. How long would Nguyen have to be a member before the lifetime membership was the less expensive of the two plans? So I've summarized the data up here, and I've given the two plans names. Plan A, Nguyen has to fork over $750, but then she only has to pay $3.49 every month. Plan B, Nguyen does not have to hand over a hefty chunk of change just to get in the door, but she does have to pay a hefty fee of $34.99 every month. After a while, this $34.99 per month is going to overwhelm the $750 that she would have paid up front under the other plan. Let's figure out when this happens. Let's define some variables. Let's let C sub A and C sub B represent the costs measured in dollars of, respectively, plans A and B after Nguyen has kept her membership for T months. Now let's come up with formulas for each of these costs. The cost of Plan A is the $750 upfront cost plus $3.49 for every month Nguyen belongs to the gym. The cost of Plan B is just the $34.99 per month charge times the number of months Nguyen belongs to the gym. Our question is, when is the cost of Plan B greater than the cost of Plan A? Well, let's write down the inequality. We've got 34.99T is greater than 750 plus 3.49T. Subtracting 3.49T from both sides of the equation, we have 31.5T is greater than 750. Dividing both sides of the equation by 31.5, since I'm dividing by a positive number, the sense of the inequality remains the same. We still have a greater than sign. I'm left with T is greater than, sounds like calculator time again, 750 divided by 31.5. T is greater than about 23.8. And I can go ahead and say that T needs to be greater than 23.8 because I'm looking for a number of whole months. So even though I rounded, I am going to get an accurate answer to the question that was asked. And the answer to the question that was asked is that the cost of Plan B will surpass the cost of Plan A after, well, what's the first number of whole months greater than 23.8? That would be 24, after 24 months. And now I'm going to turn it over to Anne so that she can work some more linear examples.
So in this last part of the lesson, we're going to find the equation of a line given two data points. We're going to start with some examples where one of the data points is the vertical intercept. Then we'll do examples where we have 2 points, neither of which is the vertical intercept of the line. We'll summarize our strategy, and we'll finish up with one application. So let's start with finding the equation of a line given the vertical intercept and one other point. So here's our first example. Here we're given the graph of a line, and we want to find the equation using slope-intercept form. So the first thing I'm going to do is identify a couple of points on this line. And I can see that I have the vertical intercept, which is pretty clear, and another point on the line. So I have the point 0, -3, and it looks like I also have the point 4, 2. So I want to write the equation of the line. So I need the value of b and the value of m. Well, the value of b I can read off the graph. b is going to be equal -3 in this case. I can also determine the value of the slope from the graph. So going from my vertical intercept to the point 4, 2, I have a rise of 5 and a run of 4. So my proposed equation is y equals 5/4 x minus 3. Let's check our work. I have here the same line. The scale's a little bit different because I wanted to try a different point. And the point on the line that I see here is -4, -8. And I want to check to see that this satisfies the equation. So if x equals -4, then y equals 5/4 times -4 minus 3. 5/4 times -4 is just -5 minus 3, and that equals -8. So my solution checks. So the equation of the line that I have graphed here is y equals 5/4 x minus 3. Let's do another example. In this example, we don't have a picture. We're just given 2 ordered pairs. The first ordered pair, 0, 8, is the vertical intercept. So I know the value of b is 8. So I have an equation of the form y equals mx plus 8. So now I just need to determine the slope. So I can calculate the slope using the 2 ordered pairs I'm given. So the slope's going to be the difference in the y values over the difference in the x values. So that's 10 over 5, which is 2. So my proposed equation is y equals 2x plus 8. So I want to check this. And I can use the point 518 and see if it satisfies the equation. So for my check, if x equals 5, then y equals 2 times 5 plus 8, which is 10 plus 8, which equals 18. So my equation checks. So let me just write a conclusion. The equation of the line is y equals 2x plus 8. Let's work an application problem. A full tank at a production facility holds 3,400 cubic feet of ultra-pure water. 2 hours after production begins, 1,960 cubic feet remain in the tank. We're asked to find a linear equation that gives the volume of ultra-pure water. We're going to call that V, and it will be measured in cubic feet. In terms of the amount of time that has passed, we'll call that T, and it will be measured in minutes, the time that has passed since production began. So the first thing I'm going to do is make a rough sketch of this situation so I have some idea about what my equation should look like. So in this problem, v will be my dependent variable and t will be my independent variable. I know that before production begins, I have 3,400 cubic feet of ultra-pure water in the tank. So I know that my vertical intercept is the point 0, 3,400. The volume of water in the tank is decreasing. After 2 hours, I have 1,960 cubic feet of ultra-pure water in the tank. But I'm being asked to find a model in terms of time in minutes. So 2 hours is going to be 120 minutes. So somewhere else, I'm going to have an ordered pair of the form 120, 1,960. So I have 2 ordered pairs. One of them is the vertical intercept, so I should be able to find the equation of the line which models this situation. So here I have the basic information I'm going to need. My linear equation is going to be of the form v equals mt plus b, and I have 2 points. I know the value of b is 3,400 because 0, 3,400 was the vertical intercept. All I have to do is calculate m. So the slope is going to be the difference in the volume over the difference in time. So I have 1,960 cubic feet minus 3,400 cubic feet over 120 minutes minus 0 minutes. So the units of this slope are going to be cubic feet per minute. Let's pull out a calculator and do some of this arithmetic. So I'm going to do 1,960 minus 3,400. That's negative 1,440 cubic feet per 120 minutes. Well, 12 goes into 144 12 times, so 120 should go into 1,440 12 times as well. So this is negative 12 cubic feet per minute. So my proposed equation is v equals negative 12t plus 3,400. Let me check to make sure that this equation is satisfied by the ordered pair 120, 1,960. So if t equals 120, then the volume of water in the tank will be negative 12 times 120 plus 3,400. Let's pull out a calculator and see if we get 1,960 for that. So I have 12, negative 12, times 120 plus 3,400. And that equals 1,960, which is what I wanted. So the equation that gives the volume in terms of time is v equals negative 12t plus 3,400. So we found a model. So now we can use our model to answer some questions. For example, we should be able to use this equation to determine how long it will take for the tank to empty. Well, when the tank is empty, the volume should be 0 cubic feet. So I'm just going to replace v with 0 in my equation. To answer the question when, I'll solve for t. So I can add 12t to both sides of the equation, and then divide both sides of the equation by 12 to determine the time. So 3,400 divided by 12 is about 283 minutes. So I'm going to round this off to the nearest minute and state a conclusion. So the tank will be empty about 283 minutes after production begins. So in all of these examples, we had the vertical intercept. Let's see what happens if we don't. So now we're going to find the equation of a line given 2 points, neither of which is the vertical intercept of the line. So now let's find the equation of the line graphed in figure 2. So here we have an equation where we have t in terms of n. So our linear equation is going to be of the form t equals m times n plus b. Now when I look at this graph, I can't read the vertical intercept right off the graph. It looks to be somewhere between 70 and 80, and maybe even halfway between 70 and 80, but I don't know for sure. So what I'm going to want to do here is choose 2 points off the graph that I can read and find the equation of the line. So here are 2 points. I have the point 560, and it looks like I also have the point 1530. And I'm going to use these 2 points to find the equation of the line. Well, let me give myself some room to work here. I can calculate the slope using the 2 points. So let me do that first. The slope is going to be the difference in the t values over the difference in the n values. This is 30 over negative 10, which is negative 3. So now I know that t equals negative 3 times n plus b. Now I need to determine b. And I can determine b using either of the ordered pairs I'm given. I'm going to work with the point 560. This tells me when n equals 5, then t equals 60. So if n equals 5 and t equals 60, then we have 60 equals negative 3 times 5 plus b. So 60 equals negative 15 plus b, so b equals 75. As you remember, that's what we guessed from looking at the graph, but we weren't sure. So my proposed equation now is t equals negative 3 times n plus 75. Well, I want to check this, and I can use the second point, which I haven't used to find the equation, in order to do my check. So my equation was t equals negative 3n plus 75, and I want to check using my second point. So if n equals 15, we have t equals negative 3 times 15 plus 75, which is negative 45 plus 75, which is indeed 30. Everything checks. So the equation of the line is t equals negative 3n plus 75. Let's do another example. In this example, we don't have a picture, we just have 2 ordered pairs. But I'm going to make just a rough sketch of this situation so that I can see what's going on. So I'm just going to call my variables x and y here. And when x equals negative 5, y is 100. And when x equals positive 5, y is 20. So making a rough sketch, I notice 2 things. I notice that the slope m should be negative because my line will be decreasing from left to right. I also notice that my vertical intercept will be somewhere between 20 and 100. Having this rough sketch gives me an idea of whether or not I'm in the right ballpark when I do the computation. So let's do the calculation. I'm going for an equation of the form y equals mx plus b. I need to determine both the value of m, the slope, and the value of b, which is the y-coordinate of the vertical intercept. To calculate the slope, I just use the two ordered pairs I'm given. I'm going to look at the difference in the y values over the difference in the x values. So I have 80 over negative 10, which is negative 8. So I know that y equals negative 8x plus b. The slope was negative, that's what I expected. Now I need to find b. I can use either of my ordered pairs to determine b. I'm going to use the ordered pair negative 5, 100. So if x equals negative 5 and y equals 100, then we have 100 equals negative 8 times negative 5 plus b. So 100 equals 40 plus b, so b will equal 60. There's a number somewhere between 20 and 100. So my proposed equation is y equals negative 8x plus 60. Let me check. So I'm going to check by using the second ordered pair that I didn't use to determine b, and that's 5, 20. So if x equals 5, then y equals negative 8 times 5 plus 60, which is negative 40 plus 60, which is indeed 20. So my equation checks. The equation of the line is y equals negative 8x plus 60. So let's do this again. Now I want to find the equation of the line containing these 2 points. Y equals mx plus b. I have 2 points. The thing I can do first is determine the slope. So the slope is going to equal the difference in the y values over the difference in the x values. So this is 8 over 6, which is 4/3. So I know that y equals 4/3 x plus b. I'll use one of the ordered pairs to determine b. I'll use the point 3, 7. So if x equals 3 and y equals 7, then we have 7 equals 4/3 times 3 plus b. So 7 equals 4 plus b, so b equals 3. So my proposed equation is y equals 4/3 x plus 3. Let's check that. So I want to check the equation using the second point. And my second point was 9, 15. So if x equals 9, we have y equals 4/3 times 9 plus 3. 3 goes into 9 3 times, so I have 4 times 3, which is 12, plus 3, and this is indeed 15. So my equation checks. So I can conclude that the equation of the line is y equals 4/3 x plus 3. One more example. Let's find the equation of the line containing the points 2, 5 and 5, 5. So I'm going to start by calculating the slope. So I have the difference in the y values, that's 5 minus 5, over the difference in the x values, that's 5 minus 2. I end up with a slope of 0. So I have y equals 0x, that's just 0 plus b. Well, now I have the equation of a horizontal line. What do I know about horizontal lines? They all have the same y-coordinate. What's the y-coordinate I have here? The y-coordinate in both ordered pairs is 5. So the equation of this line is just y equals 5. Now here, I could have made a rough sketch of the 2 points and have seen that I would get a horizontal line rather than calculating the slope. Either way, I should come to the conclusion that the equation of the line is y equals 5. So let's summarize the strategy we've used on all these examples. The first thing we want to do when we have 2 data points is find the slope of the line using these 2 given points. Then we substitute the slope in one of the given points into the slope-intercept form of the equation to determine b. We write our proposed equation using the values of m and b, and then we check the equation using the second of the given points. Let's apply this strategy in an application. So Jo is driving through the Rockies. She stops occasionally to record the temperature at various altitudes. The temperature at an altitude of 2,000 feet is 75 degrees Fahrenheit, and the temperature at 7,200 feet is 62 degrees Fahrenheit. Assuming that the temperature is decreasing at a constant rate, we want to find the linear equation that gives the temperature T measured in degrees Fahrenheit in terms of the altitude x measured in feet. So there's a lot here. So let's start by looking at the basic question. The basic question says, assuming the temperature is decreasing at a constant rate, find a linear equation that gives the temperature in terms of the altitude. So in our problem, our linear equation is going to be of the form T equals mx plus b. Our ordered pairs are going to be of the form altitude, temperature. So let's look at the problem and see what information would give us ordered pairs. So we were told that the temperature at an altitude of 2,000 feet is 75 degrees Fahrenheit. So we have the ordered pair 2,075. We also know that the temperature is 62 degrees at an altitude of 7,200 feet. So I have 2 ordered pairs. So now this problem becomes like the problems we were doing earlier. I'm going to calculate the slope. The slope is going to be the change in temperature, 75 degrees Fahrenheit, minus 62 degrees Fahrenheit, over the change in altitude, 2,000 feet minus 7,200 feet. So I have 13 degrees Fahrenheit over negative 5,200 feet. So the units of my slope are degrees Fahrenheit per foot, and I'm just going to divide 13 by 5,200 to get a numerical value for the slope. So 13 divided by 5,200 is, my calculator is giving me scientific notation, but this is 2.5 times 10 to the negative 3, which is 0.0025 degrees Fahrenheit per foot. So now I know that T equals negative 0.0025x plus b. I'm going to use one of my data points to determine the value of b. I'm going to use the point 2,075. So when the temperature is 75 degrees at an altitude of 2,000 feet. So let me do that computation. So I have 0.0025, make it negative, times 2,000, that's negative 5. So I have 75 equals negative 5 plus b, so b equals 80. So my equation should be t equals negative 0.0025x plus 80. Since I have a lot here, I'm just going to put that in a box, and I'm going to do a real quick check. I'm just going to pull out my calculator, and when I replace x with 7,200, I want to make sure I get a temperature of 62 degrees. This would correspond with my second data point. So multiplying 0.0025, make it negative, by 7,200, and then adding 80 does indeed give me 62. My equation checks. So now I can answer some questions using my model. For example, according to the model, what is the temperature at sea level? Well, at sea level, the altitude is 0 feet. This is just the vertical intercept of my graph. So the temperature at sea level is 80 degrees Fahrenheit. Let's see what other questions we can answer. According to the model, at what altitude is the temperature 50 degrees Fahrenheit? Well, I'm just going to replace t with 50 and solve for the altitude x. So my equation is 50 equals negative 0.0025x plus 80. Subtracting 80 from both sides of the equation, I get negative 30 equals negative 0.0025x. So to find x, I'm going to divide 30 by 0.0025. I know the result's going to be positive, so I'm just going to work with positive numbers here. So 30 divided by 0.0025, that's 12,000. So now I can answer the question. The temperature is 50 degrees Fahrenheit at an altitude of 12,000 feet. I don't know if Joe's going to be able to climb that high in her car, but maybe. So that ends lesson 17.